Hey folks, this is for those that missed class on Friday. We were talking about free-falling objects, and we've got problems associated with it. Most of you, if you were here on Thursday in my 7th period class, experienced a little activity where we were dropping different sizes of spheres, different masses, etc., and we found that they fell at the same rate, meaning they covered the same distance in the same amount of time. So what's causing them to fall at the same rate or same velocity? And you might say the gravitational pull, and that would be correct. But what is that gravitational pull? You can tell by feeling the weight of the ball. Weight is a force. We'll talk about those in the upcoming chapters. But what we were experiencing as well as how they fell, which is kinematics, was based on a common acceleration. And that acceleration between any size sphere is called the acceleration due to gravity. Sorry about my handwriting. We use the symbol g, lowercase g. And g, acceleration due to gravity, is a constant on our planet. And our planet has a gravitational constant of 9.8, and because it's acceleration, meters per second squared. So that's our units. Now, what is the sign? Is it positive or negative? That is going to be based on your frame of reference. Typically, my students want to stay with up is positive and down is negative. So typically, folks use a negative 9.8 meters per second squared. But I'll tell you, sometimes it's really nice to set down as positive, because if I drop an object from a certain height, their displacement would be positive, their velocity would be positive, and since acceleration is towards the center of the Earth, their acceleration would be positive. So that's just a note on the sign can be positive or negative. Okay? So we're talking about free-falling objects. A free-falling object isn't something that just is set up high and released, although that's one type, where we're elevated, little person here, and the initial velocity is 0. That's one type of free fall. And the ball will, or sphere will accelerate from 0 to a certain velocity by the time it hits the ground. But you can do a couple different things from the elevated location, right? You can throw the ball upwards, right, where the initial velocity is up. You could throw the ball, oops, I'll then leave myself much space. You can throw the ball down, right, where the initial velocity is down. So free fall, just to be clear, is once you start it with this initial velocity, once it's released, the only thing that impacts its flight is gravity, whether it's in opposition to the velocity or in cahoots or in conjunction with the velocity, which means it either accelerates or decelerates. The last option is if I am on the ground, right, and I toss the ball straight up in the air, right? Up. We aren't talking about two-dimensional velocity yet, or motion, we're just one-dimensional, so it's either straight up, straight down, okay? All of these scenarios have a constant acceleration of 9.8 meters per second squared, which means, let's see if I can get here, our three equations for kinematics, right, for constant acceleration, have they changed? No, they have not. They've actually kind of become a little more straightforward. All my accelerations, I know what they are. I don't have to calculate them. They're all g. Now, another thing people might want to do is change the x's to y's, right, as far as initial position being in the y-axis as opposed to the horizontal x-axis. It's all based on your preference, okay? So when I see this, you could take time to change it, right? But you don't have to. All right. So I want to give a couple hints, I guess. Hints with working with motion. Okay. So let me go back and add a page. I've got these 4 types of motion. Okay. One, and this is the position versus time. One, I'm an elevated cliff, right? And I'm just dropping the ball, right? Initial velocity is 0. I'm starting at a height. Remember, the motion is parabolic, so over time, right, it just starts at the peak where velocity initial equals 0. If I'm at a spot where I am tossing the ball upwards, right, over time, I'm still at this elevated position. It's like this. The problem-solving technique is, where is my 0? And it's at that max, right? Max position where this has a velocity equal to 0. So you can start treating things a little differently. You can break a problem like this into 2 sections, right? One that has the upward to its maximum location. You can find the height to get there and the time to get there. And then the second part of that really is a free fall scenario where it starts with 0 velocity and it takes that amount of time to finish or get back to normal. Okay? Oops. Let me get to that. Let me get my pens worked out. We have the scenario where you have the velocity where you're aiming down. That just is a little bit quicker. Okay? And my final scenario is where I'm on flat ground and I throw it straight up. Right? So I'm at 0, x of 0. Throw it up and down. The nice part about this one is that Vmax creates a symmetrical array. Okay? So this maximum height, x max, sorry about that, has that velocity equal to 0, and that can help solve some problems or problem solve for a shot where you're throwing from the base. The time to go up is equal to the time that goes down. The initial velocity, right, is going to be equal to the velocity right before it hits the ground, but in an opposite direction. Okay? So those are 4 different scenarios, and hopefully some hints to be able to help problem solve when you're reading through some of these constant acceleration problems dealing with free fall. Okay? So let me get to the next slide. This is just an example. We'll go through 2 examples if I have time. And we did these in class. It says, estimate how long it took King Kong to fall straight down from the top of the Empire State Building, 380 meters high. Okay? So I got the monkey, right? It's 380. We've kind of determined with that this is 0, right? And then up is positive. So we've set our frame of reference. I'm going to list out my factors, x of 0, x, v sub 0, v, a, and t, and I'm trying to find how long it took, right? So up is positive, that means my acceleration is negative 9.8 meters per second squared. My initial velocity, he did free fall, so its initial velocity is 0. I started, my position is a positive 380, and my final position, honestly, is 0. He's down to ground level. So which equation am I going to use? Ones that have time in it, either this one or this one, and it looks like the only one that deals with position is the second equation. All right, so I'm going to help me remember the equations, write down the equation first. Right, and from here I'm plugging it in. Final x, 0, initial x, 380. Initial velocity is 0, so that's nice, that'll go to 0. Plus 1/2 negative 9.8 t squared. I simplify that, I get 380, right? And that 1/2 times negative 9.8 is negative 4.9 t squared, and it all equals 0. I do my algebra. And I can ultimately solve, right, for t squared. So I divide by 4.9, and I get t squared. Oh goodness, I think it's 77. 77.5. So t equals, when I take the square root of both sides, 8.8 seconds. All right? So we're using the same equations, the same process, because we've got constant acceleration. We're reading the problem, trying to find our clues. The clues that we had 0 velocity initially, and the final position was 0, and that our acceleration was negative 9.8. The second part of this question says estimate King Kong's velocity just before landing. Okay, so again, writing it out. I know we found some stuff already. Right, 8.8 seconds now. And then I've got negative 9.8 meters per second squared. Initial velocity, 380. And final. I want to find, right, my final velocity, so I can either use my first equation, or if I wanted to, my second equation, or third equation. I'm going to use the first because it's easier. V equals V sub 0 plus AT. Writing it out so I can keep remembering it. V sub 0, 0 plus negative 9.8 T. And that velocity is what I want to find out. And ultimately, and time was 8.8 seconds. So the product of those, 8.8 times 9.8, gives me a negative 86.2 meters per second. Question for me, what's that negative mean? The negative means down, right? The negative means down, right? So those are our two examples. Those should help you prepare. I hope the hints, the clues, will help you problem solve for the 4 different types of motion. 3 will be predominant. The throwing the ball down, not so often, okay? So throwing it up from a cliff, throwing it down, or releasing it from a cliff, and then being on level ground and tossing something up in the air. So I hope that helps. I hope you have a great weekend. It was really fun to see you out there during the assembly, and hopefully I'll see you tonight at homecoming, and I'll catch you guys back on Monday. Have a great night.